When I talk about reduce operations, the remainder ones, let's start from 9. Hmm, 9. Okay. This is just displaying a summary string for a numbers array. Your numbers is a number stream array, and all I'm checking is first what I do, I convert the integers to string using this function, and then we're just going to concatenate them to display them. See, a plus, and you just add this delimiter here. So when you go here, this is what it prints. Now next go to longest string. We want to find the longest string of the words array. Now words.stream, what you're going to do is in a comma b, you get your reduce identity. The second one is an accumulator condition. Remember, it's your condition to assign values based on a condition. So you do a dot length greater than b dot length, then you assign a, else you assign b. So then you get the longest word, right? So hello world Java streams is the longest. It's at 6, 7, right? The rest are all 5. So streams is the longest word. You can also use an optional. So just in case you have a null, you don't have to worry about nulls. In that case, you're not going to use an identity here. Instead, you'll use an or else, and you'll set the value here. Let's go to parallel reduce. Parallel reduce is when you run your operations in parallel, then it's faster. It's twice faster in my laptop, which is only 4 cores and 8 threads. So what you're going to do is you're going to create a large set, which is about 10 million numbers. And then we're going to run sequential processing and parallel processing on it. In parallel processing, the key important thing is it's split into chunks. And each chunk will have its own identity value and process independently. And that's how it's able to get things done faster. And then the results are combined into one combiner functions. So let's go and look at the logic, how we're doing it. In this case, this is without, we're going to add 10 million integers, and we're not using streams, we're just using reduce. So you just have your identity, we set it to 0, and then you're adding an accumulator, which is the sum, integer colon sum. And then in parallel stream, what you do, we set a reduce. Our reduce is 2 other parameters, integer identity, and you got accumulator, and you have a combiner. Accumulator is integer sum, combiner is integer sum. So what we're basically telling is divide the 10 million set into chunks. Each chunk starts with its own identity, and we tell this thread, okay, you take this identity from this thread to this range, you go and add it up. And then, so that's what the accumulator does. They have different identities and they do different parallel processing. So in this case, 8, and then binary combiner, what the combiner we're saying, combiner, we're again telling the combiner, do the total add. So you see, this is the syntax for parallel streams. You separate it into chunks. I think it's well written here. In parallel, Y identity is required for parallel processing. You split it into chunks. Each chunk has its own identity value and process independently. And then this one becomes the accumulator. And then they're combined in the combiner function, which is the combiner. So in this case, so now this is where we're calculating the difference. Let's go and see if it made a difference. It did. Sequential time, how long did it take? The sequential stream, it took 125 milliseconds. And the parallel stream took 58 milliseconds and used 8 threads. That's my logical max for my laptop. What is the performance speed up? Parallel was faster because the performance was higher, 2x times. Now, this is just a junk case where this messes it up because, you're doing a identity of 100. Identity should always be 0. It's going to be a default value. When you set it up to 100, your processing gets messed up. Let's look at custom object reduction now. We have this sample list of orders. And we want to, what is our condition? We want to find maximum amount first. 100, 200, 150. So what's C1? So what we're going to do, we're going to get a stream, sample orders.stream will be the first thing. Then we're going to compare get amount, O1, reduce O1, O2. We're not using identity here. Reduce O1, comma O2, comma O1 dot get amount greater than O2 dot get amount, O1, O2. Since we are using an optional here, if you notice we use an optional, right? So then we're printing out the order, we're doing the entire order object to toString, or else we're saying we want to print none. And then you want to do sum of all amounts. What would you do? You would do double dot sum because amount is a double. You would say map only get the amounts and then get to do a double dot sum. And then reduce to combine all list items. In that case, what would you do? Your initialization, initially you're creating a dummy new array list to store values. And then you create your list with list 1 and then you add all list 2. When you do add all, if it's not there, it's not going to add it again. So you add both your lists and you return your combined list. So it's going to go and add all the list items. And then you print all your items. So let's go look at these custom object reduction. So order with max amount, it went and found 200. Then total amount came to 450 and all items is ABCD.